Welcome to another cloud computing news. We're going to be taking a look at a really interesting project from AWS Labs today. AWS Labs has released a project called LLRT. So LLRT is the low latency runtime, an experimental lightweight JavaScript runtime designed to address the growing demand for fast and efficient serverless applications. AWS, the context of serverless applications here is going to be AWS Lambda. AWS releasing their own is really interesting. And why would they do this? They don't specifically say. It's built in Rust, utilizing QuickJS as a JavaScript engine, ensuring efficient memory usage and swift startup. So I feel like this to me is a little bit of their thesis on like why they released this, efficient memory usage and swift startup. So if we look at some of these statistics down here, which we will in a second, you'll see that cold start times, if have kind of been like the thing that people kind of harp on when they talk about AWS Lambda performance. So cold startup times are depending on the language, can be excruciatingly painful. So if you've got a serverless application and you're waiting 2 or 3 seconds to even begin servicing a request, like that's sometimes that's just completely unacceptable in terms of performance for your application. So I think what AWS is trying to do here is one, address that concern, right? The cold startup time concern, and to look at, finding a runtime or building a runtime that's more efficient for users, because really you actually pay for efficiency, or I guess rather you pay for inefficiency. So if you have a poorly optimized runtime, if it takes 3 times as long or 10 times as long to, start up and run a function as it should or could, then, you actually as a user pay for, that extra time. So the other thing that's interesting and they don't state here, and we talked about this a little bit with the conversation around Rust last week, is that not only is this going to be more performant in terms of memory usage, but there should be some practical security benefit here to using a Rust built Node.js code interpreter versus like, the actual Node.js runtime, which I believe is built in C or C++, maybe both, or maybe just C++. It's definitely not written in Rust. So this is, going back to the whole Rust conversation, like this is a really interesting thing that they're doing here. I actually believe I saw a Python interpreter that was being built with Rust too recently. I don't know what it is, and it's not really, relevant to this conversation other than that it's written in Rust. So if I find the link to that, I'll post it in the description and we can, you can take a look at it there. But I do want to take a look at these statistics. These statistics are very interesting. And what AWS has done here is the statistic that I really want to take a look at is the P99 statistic for cold starts within the context of a Lambda function. So this first like graphic here is LLRT. The second graphic is Node.js version 20. Processor architecture is the same on both, and the memory allocated to the environment is the same in both. And we're doing the same thing with both. This is a request to write a record to DynamoDB. So essentially all things are held constant. We're doing the same thing. We're doing it on the same processor architecture. We're doing it with the same amount of memory. So this number right here is the one that just blows me away. And I think it's the most compelling. It's the number with the greatest overall like a delta between any of the numbers that we're going to take a look at. So this is the P99 statistic for cold start time between Node.js 20 and LLRT. So for LLRT, 83 milliseconds. That's fast in and of itself, right? But man, if you compare that number to the Node.js cold start time, the P99 statistic, 1660 milliseconds. So you're talking about over a second and a half for Node.js cold start in a Lambda context versus 83 milliseconds. So less than a tenth of a second, right? Yeah, less than a tenth of a second for LLRT to start up versus Node.js. That is that's a very compelling number. And then we'll take a look at let's look at the warm start too. So P99 warm start for LLRT, 36 milliseconds. P99 for Node.js is much better. Their P99 for cold start and Lambda is right around 200 milliseconds. So we round this up to 40, we round this up to 200. That's, still 80% better. But this number for, just looking at the Node.js runtime itself, it's cold start versus its warm start. There's a big delta here. And for LLRT, that number is not quite as significant, right? So, this number here is just already like it's like they squeezed everything they could to get this number as low as they could. So the warm start, the difference between warm start and cold start isn't quite as drastic with LRT, but it's still like it's almost one third. If you're building a new serverless application on AWS Lambda and your runtime language is Node.js, it is definitely worth taking a look and seeing if you can use LLRT. And the thing that's probably going to um, dictate that for you to some degree is going to be whether or not you have API coverage. So the other thing that, AWS mentions here is that LLRT only supports a fraction of the Node.js APIs. It's not a drop-in replacement for Node.js. So like, every API that's implemented in Node.js is not implemented in LLRT. So, do some digging, figure out whether or not this is going to work for your project. They're also saying like, don't anticipate us ever 100% covering every API that's available in Node.js within LRT. We're not going to do that. Out of the box, you have pretty decent coverage. So buffers are covered. Streams are partially covered, not native. So it's implemented, but not native, which is fine. Um, TLS not implemented, but should be. Fetch is implemented. File system promises are implemented. File system itself is not implemented, but will be. HTTP and HTTPS not implemented yet, but will be. So path implemented, timers implemented, UUID, crypto processing, coding console, events, ECM, CJS, await, and other modules. Well, that's pretty generic. But I mean, man, like, for that performance benefit, like you have a pretty decent basic set of API coverage. So thanks for tuning in. Like, subscribe, share, and we will catch you on the next one.